Hello, welcome to Notes 6.02. Today we're looking at what's called the side splitter theorem. It's a new rule that helps us with our proportions. We're also going to focus on some area and perimeter problems. Okay? So the side splitter theorem states, if a line is drawn parallel in a triangle, it splits the sides proportionally. So looking at the diagram here to the right, we have a little triangle BXY, and we have a larger triangle ACB. With those two triangles, they are said to be similar. Triangle BXY is similar to triangle BAC. They kind of go in their corresponding positions. With those triangles being similar, these angles are congruent because similar triangles have congruent angle measures. And that we're going to use a little bit later when we do some proof writing. So if I just kind of give you a peek ahead, we're going to be doing similar triangle proofs in a couple days, all right? Which talks about sets of angles being congruent. But again, if this line is drawn parallel to its opposite side, it divides the shape proportionally. And we've looked at this before when we had x and y being midpoints. So if x is the midpoint, let's say that bx is 5 and xa is 5, making the whole side a to be 10. Well, if by was a little bit longer, let's say that that's 7, and yc is 7, those proportions, 5 compared to 5, is equivalent to 7 compared to 7. So how we're going to set up these proportions is that this top piece compared to its bottom part is equivalent to this top piece compared to its bottom part. So it's called the side splitter theorem, where we literally split the sides to make a proportion. So that 5 over a 5 is in a proportion to this 7 over a 7 to make this big proportion here. Okay. So what we do is we split the sides proportionally when this line is drawn parallel in the middle. Now, we're not going to always have all the measures, right? One of these is going to be the unknown piece that we're going to be looking for. So looking at number 1, given triangle ABC, D is a point on AC and E is a point on BC. So triangle ABC, D is a point on AC. So AC is down here at the bottom. Now, how you draw your pictures might not be how you really, they're not always drawn to scale. Let's say it like that. So D is a point on AC, and E is a point on BC, such that DE will run parallel to AB. And that is true. So this picture is kind of a rotation. I just turn my paper a second, where C is up top and these sides are parallel. So if you need to rotate your picture around or flip some letters around and maybe put C up where B was, it's going to affect how you draw it. We're going to still use it how we drew it. C to D is 5. So C to D, this measure is 5. CE is 7. AD, A to D is 6. Find BE, so that's my X, and CB. Well, CB, be careful here, is this whole side. So once I know X, we would take X and add 7 to find that CB. But what we're first going to do is use these 4 pieces to make a proportion. And what I said before is that this line parallel here splits the sides proportionally, so that 5 compares to 6. So again, I'm thinking the top to the bottom. 5 compares to 6. Excuse me. As 7 compares to X. So again, I did the top over the bottom if we think C is that top point. 5 compares to 6 as 7 compares to X. and we set up our proportion. So we get 5x equals 42. We get a decimal. Decimals are okay. And 42 divided by 5 will give me the x equals 8.4. That's okay. There wasn't a perfect scale factor here. So 5 doesn't become 6 by adding 1, okay? So again, remember we're multiplying by really 1 1/5 times bigger. So 7 times 1 1/5 times bigger ends up being 8.4. Okay? So our proportions are our friends. So remember to set up a proportion. With that said, if x is 8.4, answering our question, BE equals 8.4, and CB, C to B is this whole side. So if this one is now 8.4, we're going to take 8.4 plus 7 more. It's going to give us that CB is 15.4. That's not going to change. If the 7 plus 8.4, that's off your screen, sorry about that, gives us 15.4. The next picture is drawn a little bit more normal, I should say, with that A up top and the parallel sides going left to right for us. So looking here in the diagram below, 8 of triangle ADE, the large one, B is a point on AB, and C is a point on AD, just like we just drew, such that BC is parallel to ED. So that's a key fact here. These lines being parallel form these corresponding equal angles. So this angle copies to paste here. This angle corresponds to here. If AC is x minus 3, so x minus 3 is going to go here for A to C. BE is 20, right here. AB is 16, and AD is the whole measure. A all the way down to D is 2x plus 2. We need to set up a corresponding proportion. So those 4 pieces, it's really important to carefully label your picture because this x minus 3 and this 16 are on the same kind of positions, okay, to correspond. But this 20 from B to E, we don't have a matching measure from here to here. Okay? So what we're going to do, if this is the whole side, meaning both parts added together, then we're going to find the whole side over here. It's going to be 36, 16 plus 20. And my little proportion that I suggest doing is a part of one side compared to its whole. So x minus 3 compared to the 2x plus 2 will equal part of the other side, the 16, so those are in the same position, as 236. So notice we didn't just take the 4 digits they gave us in the problem and put them in a proportion. You really have to label the picture and understand what parts match up to correspond. Cross multiplying, 36 times x minus 3 is the one direction, equals the 16 times the 2x plus 2. A little hint for some of you, make sure you put the digits in front of the binomials. Okay? So putting these parentheses in helps the distribution with your 16 and your 36. So here we have 36x minus 108 equals 32, 16 times 2, x plus 32. Be careful solving. I like to move the smaller number over, so I'm going to add 108 to both sides. Just like I'm going to subtract 32 x's from 36 x's. So we'll have 4x left over on this side equals 32 plus 108 is 140, making x 35. Because 140 divided by 4 gives us 35. But we're not done. We found x to be 35. So what that tells us is that this x in here is 35, this x in here is 35. What they're asking for, and we have to make sure we answer, is to find the length of AC. Well, A to C is this x minus 3. So our answer is going to say AC equals 35, which is our x, subtract 3, AC will be 32 as a final answer. So we really have to make sure we're going back in and answering exactly what they're asking for, that we're not just stopping at a value of x. Exercise 3 is starting to talk about perimeter. All right, and we're going to do some more practice with perimeter on the back of this as well. Exercise 3 reads, Bob's sailboat has 2 sails that are in similar triangles. So we have a boat. We have one triangle, and maybe a second triangle as 2 sails. Okay. The larger sail, so I like to draw my triangles not overlapping anymore. So the larger sail has sides of 16 feet, 30 feet, and 34. So I'm going to put on a 16, a 30, and a 34. Again, those 3 measures tell me that this is scalene, so all different sides. If the shortest side of the smaller sail is 4 feet, some of you are seeing a scale factor there, okay? What is the perimeter of the smaller sail? Okay. What we can do is we can make a proportion of a side over its perimeter equals a side of the other shape over its perimeter. Okay. So we're going to make up a proportion. Side compares to a perimeter as a side compares to a perimeter, so that we have some corresponding pieces. We have enough information here to calculate its perimeter. So what we're going to do is we're going to go in and add our 3 sides, 16, 30, and 34. We get a perimeter of 80 for the first sail. So we have a side and a perimeter. Now the reason I'm using the 16 is because the 16 is the shortest side, and the only measure I know of the smaller sail is this 4. So some of you, again, are seeing that scale factor. From a 16 to get down to the 4, we divide by 4. 80 divided by 4 will give you the new perimeter. But there's more complicated examples where these proportions are going to help out. So we're going to set up the proportion. 16, the side of the larger sail, compares to its perimeter, 80, as 4 compares to the perimeter, which is what we're finding. So we're asking for the perimeter of the smaller sail. That's our variable here. That's our missing piece. Okay. So 16 compares to 80 as 4 compares to x. Well, when we take cross products, we get 16x equals 320. Divide by 16, and we'll find x to be 20. So here the perimeter equals 20 feet. So again, we set up a proportion. A known side over a known perimeter equals the side we have over the perimeter we're finding. Okay. There's a couple questions very similar to this on your homework tonight. Okay. So please try to match up what questions you're doing here with your classwork, and I'll try to give you a few pointers at the end of our notes video. On the back, perimeter and area rules. There's a couple key features about these perimeters and areas as we kind of work through this first question here. Perimeter, remember, is the sum of all sides. We did some work on that at the beginning of Unit 5. Area of a parallelogram or a rectangle or a square, because rectangles, squares, and parallelograms are all parallelograms, is the base times the height. Area of a triangle is a half the base times the height. Parts A, B, C, and D here are kind of to help us understand how the perimeters and areas are related within a square. So if we have this square ABCD, and it has a perimeter of 12, if the length of all four sides is 12, well, 12 divided by 4 equal sides gives us that each side is 3. So here we know each side, AB, is 3. The perimeter is 12. If another square, okay, and a little key fact here is that all squares are similar, right? Because their angles are always congruent and their sides are always going to be proportional. The new square EFGH has a perimeter of 36. Find its area. I missed this part. So if the side AB was 3, the perimeter is 12, its area equals 9. 3 up and 3 over means we take up 9 square units. New shape, perimeter of EFGH has a perimeter of 36. So all four sides add to 36. Divide by 4. We get each side is 9. So if this side is 9, 9, 9, and 9, that gives us the perimeter of 36.
Good afternoon, teachers and students. You may dismiss.
So each side is 9. Its area equals 9 by 9, gives us 81 units squared, or square units. So our area here is 81. Now the area of the smaller one was 9. How does 9 become 81? How does 3 become 9? How does a perimeter of 12 become a perimeter of 36? Is what we're going to look at here. So if we just decide the scale factor from square ABCD to EFGH, we're going to take a side of the new over a side of the old. So from ABCD to EFGH, the new side is the 9, the old side is the 3. This scale factor, most of you already knew, was 3. Okay, this perimeter got 3 times bigger. But did the areas get 3 times bigger? Does 9 times 3 give me 81? It doesn't. So this scale factor only works for perimeters. Okay? So a side of ABCD being 3, and a side of EFGH 9, and their perimeters 12 to 36, those are equivalent proportions. 3/9 equals 12/36. 3 over 9 is the same decimal equivalent as 12 over 36. Something you can do to check that is you can always check your cross products here. 9 times 12 gives us 108. 3 times 36 also gives you 108. So if you check the cross product, those are equal. Okay? So your perimeter rule is going to be any ratio of sides is always equal to the ratio of perimeters. Okay? So that's one rule here. When you're looking at perimeters and sides of a figure, you take the ratio of your sides, one side to its corresponding side, equals the ratio of the perimeters. When we're talking about the areas, it's different. How does a 9 become an 81? So 3 times 3, scale factor 3 gets you to 9. But how does 9 become 81 using multiplication, right? So a side of ABCD is 3. Its side of EFGH is 9. How does 3/9, 3 compared to 9, as the area 9 compares to 81? So if I write it like this, a side over a side, the area over the area, fill in those 4 blanks. Okay. How does 3/9 become 9 over 81? gets squared. 3 squared gives you 9. 9 squared gets you 81. So the rule down here for rate areas is that you take the ratio of sides, so whatever fraction you have, and you square it to become the ratio of your areas. We'll look at a question like that in a second. Okay. I'm going to go back to another perimeter question. Exercise 4. The base of an isosceles triangle is 6 and its perimeter is 24. So the base of an isosceles triangle is 6. Sorry about that. Its perimeter equals 24. I could find the missing sides, but I don't need them. The base of a similar isosceles triangle is 10. So this triangle getting larger, 6 becomes 10. Again, some of you don't recognize that nice scale factor there. What is the perimeter of the larger one? That's what we're looking for. Seeing that we're talking about perimeters, we take a ratio of the sides. 3 compared to a 9 were the sides we were talking about up here. Here we have a 6 and a 10. So we're going to set up a proportion. 6 compares to 10, a side compares to its corresponding side, as the perimeter of the smaller compares to the perimeter we're finding. So here we get 6 times x equals 240, making x the new perimeter, 40. So we're kind of utilizing the rule we just solved for up here with some squares to find the new perimeter. So again, you take a ratio of the sides, 6 compares to 10, 24 compares to x. Now they like to ask you these ideas in really complicated fashion on these SAT type questions. So I'm not going to be talking about the regions as much anymore. I mean, it's still a thing, it's still important, but I want to focus on SAT type questions that I know most of you will be taking in the next year or so. In the diagram below, we have triangle EBC is similar to triangle RST. So the A and the R, T and the C are in the same position. Which statement is not true? Angle A is congruent to angle R. That is true. Angle A and R are in the same position. Those should be equal. AB compares to RF as BC compares to ST. AB compares to RS, so I went from here to here, as BC compares to ST. That makes sense to me. AB and BC are two sides of this triangle, the bottom side and the right-hand side. RS is the bottom side to its ST right-hand side. So that is true. Those are in corresponding positions. AB to BC. AB to BC as ST is to RS. This one's a little bit backwards. Okay, read it again with me. AB is to BC. So this is the bottom side compared to the right-hand side, as ST, the right-hand side, compares to RS. Looking across our fractions, does AB and ST in the same position? They aren't. So this is going to be our answer. A lot of you have been like, yeah, those are all fractions, they look good. But this one looks crazy. Well, all this is saying is that the sum of these three sides compared to the sum of these three sides equals this side compared to this side. This is essentially that perimeter rule we were just talking about. These are talking about the perimeters compared to the sides. That does solve a proportion, so that works. That's really it for the notes portion of today's class. Again, we want to practice setting up those proportions, trying to read through these regions and SAT style questions. But moving over to classwork 602, when you see these questions like 1 and 2, you should be drawing pictures. A triangle has lengths who are 3, 4, and 5. A similar triangle could have which set of measures? So you have to decide 3 times what, 4 times what, and 5 times what do you get these 3 measures to match out? And this is where a pencil could help. The 6, 8, and 12 make sense from a 3 times 2, 4 times 2 if you're looking at scale factor. 5 times 2 doesn't give me 12. So it's not going to be choice 1. So this is like a guess and check idea to go through your 4 choices. Question number 2. The sides of a triangle measure 5, 8, and 13. So we're going to draw a triangle with 3 sides that are not equal. Find the length of the longest side of a similar triangle. So a similar triangle, that's not as similar as it mentioned to be. There we go. Okay. Find the length of the longest side. So this is 13 is the longest, so x is going to be what we're looking for, whose perimeter is 65. Well, we can find the perimeter here by adding up these 3 measures. And you're going to have a side to its perimeter equals a side to its perimeter. So I'd like you to see number 3 from the notes if you need help with number 2. Okay. Questions 3A and B, you should really be setting up a proportion. And a little clue here is to redraw the 2 figures. The little triangle has sides of 6 and x. The big triangle has a side of 18 to 16. Should help you with your proportion. Same idea here for letter B. Okay? The 8 and the 20 are a side and a part. Okay? But you could really find the 12 here. See what you can do with letter B. It's really kind of making you think a little bit. Number 4, please make sure you label the diagram accordingly. Be careful to read the letters correctly. A lot of students make mistakes just labeling your pictures. Couple clues on the back. Here is an application question. The diagram below shows the rafters of a house and a garage. The house rafter is parallel to the garage rafter. So these sides are parallel. So what you form are 2 overlapping similar triangles. So your similar triangles are kind of hidden in there. 13 compares to x. As this whole side, you might want to use an 18, compares to the other piece, 12. And here you're going to round to the nearest foot, so you might get a decimal. This is a little clue that you might have a decimal answer. For number 6, I would draw 2 triangles, A, B, C, and D, E, F. Label in the pieces here to what makes sense. Try number 6. Number 7, I would see note, I believe it's 5.04 on your directed line segment questions. If you need some graph paper to try that, please do. This one is pretty self-explanatory, even if you just sketch it on your paper. And number 8, the ratio of corresponding sides of 2 similar squares are 1 to 3. My suggestion is to draw 2 squares. And that's it for today. We kept it under 30 minutes for you. Have a great afternoon. Thank you.